Hi everyone, Robin. I have spoken at the Sydney Elixir before, a meeting before, and mainly most of my talks are thinly disguised things about aviation and simulators and drones and drone communication things, but I try to emphasize the Elixir side of things. So this is related, and in fact this is actually a sort of second time I've come to this topic, because my very first talk, I was involved in the Erlang user group in Sydney before, but the first talk that I gave at Elixir was actually about trying to handle a similar problem, which is if you're doing a lot of engineering calculations and you're writing it in code and you're not too sure of yourself, you really want to be incredibly careful that you don't muck up your units. And so I actually put up something on Hex called def unit, which sadly turns out to be, even though it had some fun things in it, and I did the presentation, and I think it confused a lot of people before they saw the subtle madness, brilliance behind the madness or whatever. But the problem was that it was based on some assumptions about how dialyzer works, which were incorrect. And so this is me returning to the problem a few years later, with something that wasn't so reliant on the type system of Elixir, and more a bit manual about how to handle units. And so this is, yeah, like I said, do a lot of drone stuff. For the people who didn't see before, that's the propeller for the aeroplane behind me, and that's we've been involved in some drone competitions. I'm currently writing a library, Elixir library, which contains a lot of the formulas which are inside this book, which is one of my favorite aeronautical engineering textbooks. And it has lots of formulas in it that look like this and this and this sort of thing. And and the thing about this is, because aeronautical engineering is such an American thing, most of the books are are in US units. And so that means when you're sort of working in a mishmash of metric, and that it becomes very important to know exactly what units you're talking about. And to make all these formulas easy enough to put in code, you don't want to be constantly having to do all the manual conversions backwards and forwards. So, so just starting again, or going in here, here's my cursor, here we are. So I'm writing a library to handle units. And so we're going to talk about, just a quickly reminder about what dimensions and units are, and how I represent them in Elixir, how we can convert units within a dimension, like change from feet to inches or feet to meters. A little thing that I came across, because this is really the first time I've used with, even though I've been programming Elixir for a long time. I'm not saying that this is necessarily the right way to do it, but it was just my way of approaching a problem I came to with using with. Then we're going to talk about overriding operators, or implementing operators, and then how can you override the operators that the kernel provides, so that you can make them do more than the kernel ones do. Okay, so very quick review here. Dimensions are things like length, mass, time, area, velocity, power, as Paul was saying. And units are the particular scales that we use to measure those. And so, yeah, and so there is actually something on Hex called unit. There is actually another library called unit that already been taken, but it's mainly talking about doing these sorts of conversions, just converting in between different kinds of units over here. But yeah, when we're talking about engineering, like we're talking about things like pressure, and pressure is, a force applied over an area. And so you're constantly having to work with different dimensions and stuff in aeronautical engineering. And if those are all being, measured in pounds per square inch, or pounds per square foot, or kilograms per square meter, or whatever, you really don't want to get those sorts of things wrong. If we wanted to represent this, first of all, there's a whole load of little names here. And so the typical thing you do in Elixir is, if we're going to start describing units and dimensions, we're going to want some, use to make up some atoms that correspond to all of these units and dimensions. So this is a type spec for people who aren't familiar with those in Elixir. You can, for people who don't know about these very briefly, you can completely ignore all the type spec stuff and your code would still work, but there is some static, there are some tools that are provided, one called Dialyzer, which allows you to do static type checking of your Elixir programs. And so this is in the syntax that's used for type specs. But the other thing that type specs are useful for is communicating to other programmers what your functions, or what the arguments are that your functions expect. And so that's why I'm showing you this, because you also see this in all the Elixir documentation explaining what sort of types we expect to see. So here are all the different sorts of dimensions and atoms to represent different dimensions, and then here we'll have some atoms to represent units, and we'll break them down into some subtypes. So in case we need to refer to all the force units by one name, that'll be newtons or pound feet. So how do we represent? So given that, I mean, there's not really very many options about how we might represent that in Elixir. So I'll present to you a 10-meter tuple. Okay, so if we wanted to, so you've got a value 10 and we've got some units, so making a tuple out of them is probably the right thing. So that's probably the largest tuple anyone has ever seen. I don't know, sorry, that's a bad joke. And I did this deliberately to show people, just to remind people that that actually works in Elixir. It's one of those things that you read earlier on in the, I don't really know. I actually find it sometimes useful for large numbers because it does make it clear how many zeros you've got. But yeah, that's just in case you didn't know you could do that. That's a valid number. So the next thing we want to do is, let's say that we wanted to express this 10,000 millimeters. Builders work in millimeters so we did a 10,000 millimeters instead of 10 meters. We could have written 10 meters. But say we want to convert it. So I want to have a function that lets me do something like this. Okay, I want to be able to take this 10 meters or 10,000 millimeters, and I want to have a function called 2, and I want to say the unit that I want to go to is feet, and I want it to be able to give me the answer like that in feet. Okay, so that's what we're going to, so we're going to do that. The first thing we need to know is how many millimeters there are in a foot. Or we need to know all of these scaling factors so that we can translate backwards and forwards between units. So in our code, we're going to need some sort of table or lookup to know what all of those factors are. And so we have this units map, and the keys are the atoms that we're using to identify kilograms, grams, pounds, slugs, and blobs. Did you know that those are actually real measurements? A slug is about 14.5 kilograms, and it's the weight that is accelerated at 1 foot per second if you apply a pound of force to it. So I don't know if it's related to bullets and the word slug being used for bullet, but even the better one is blob. I quite like that. Yeah. A blob is even bigger and blobbier than a slug because it's the weight, which is about 175 kilos, that accelerates at 1 inch per second if you apply a pound of force to it. Anyway, sorry, enough interesting little side things about obscure imperial units. They might be related to Jabba the Hutt. Sort of seems imperial, sort of have a Star Wars sort of tone to it. Jabba the Blob. So dimension of unit. It is weird doing. I can see some people joggling around in their chairs with amusement, but I can't quite tell if people are groaning or laughing. It's very strange doing an online presentation. Okay, so we've got tuples in here. The values are tuples. This is the dimension, and we'll come back to that later when we talk about how we convert between dimensions. Here is the scale relative to our home unit. In every dimension, we're going to have a home unit, like our Rosetta Stone unit that we're going to be translating things through. And you can see them because they've all got 1. Our home unit for mass is kilograms. 1 kilogram is 1 kilogram, but 1 gram is 1,000th of a kilogram, and a pound is 453 grams, and so on. So we've got these little tables here that will give us the conversion factors that we need. And that last thing is just we have a helper function that will give a description of a unit if we're looking at one of those tuples. Okay, so if we're going to convert millimeters to feet, we're going to zoom in on part of this down here. Okay, so there's our millimeters entry. A millimeter is, 1,000th of a meter, and a foot is, well, 304.8 millimeters, or 0.3 of a meter. So to do the translation, just the maths, that's I've labeled these so you can see what they do in the code in a second. There's the unit we're going from, millimeters. There's the unit we're going to in feet. There's the coefficient. C stands for coefficient. That's the scaling coefficient, which just means a number that you multiply things with. That's all it is. For from, and that's the coefficient to scale to. And so what we do as our input is 10,000 millimeters. Okay, there's our input. 10,000 times 1,000th is 1. Oh, sorry, is 10. No, yeah, sorry. Actually, see how easy it is to get confused. There you go. So that's 10 meters. We've converted into meters by timesing it by that factor. Then we divide it by the 2, and that will give us the answer in feet. So 10 divided by 0.3 is about, 32 or something like that. Okay, so that's the sort of maths that we do a conversion. We go from the from unit to our home unit, which is meters in this case, and then we divide it by the 2 coefficient to get feet. But what about something like temperature? Because if you're going between Celsius and Fahrenheit, you can't actually do that because there's an offset, because 32 degrees something or other, like the zeros aren't the same, you can't just scale them. And so in our little lookup table, we have little cheat functions where if you're in a weird measurement like Fahrenheit, which doesn't scale with, it actually has, we have to add 32 to it or whatever to get it to line up with centigrade, then we just have a little tuple of functions, which this one is the one that will translate to the home unit. We'll take a Fahrenheit value to Celsius, and this one will take a Celsius value back out to Fahrenheit. And those are functions that are too boring to actually show you. But that's how our little lookup table can cope with those sorts of things. So next thing is, what does our to function look like? Okay. I'm sorry. By the way, I'll just say that because I knew this was on Zoom and I knew that getting all the technology stars lined up, I've used simulated typing in a presentation, which I do apologize for. I do actually have, just so I do actually have a terminal. Hey, where's the terminal? Oh, I have a terminal which is now not open anymore. I'll go back to Keynote. Thank you. I do actually have a terminal in which I can run some samples during questions, but I'm just going to, I'm just doing simulated typing for now. So it's as fast as Lieutenant Data would have typed if they'd given him a real keyboard instead of just a funny plastic set. So, okay, so here's our specification. We're going to take one of these, qualified values, a number with a unit, and then we're going to convert it to this unit, and the output's going to be a number and a unit. So here we go. So there'll be a, we're going to do some looking up of the unit details. I'll leave that out for a sec, but basically all we're going to do is, here's our numerator, and we're going to multiply it by the from coefficient. If that was instead, if we're doing temperature and that was a function, we'll look up the from function and we'll pass the input to it to convert into the home unit. And then the output is we just divide it. We either divide it by the to coefficient or we pass it through to the to function in there. And then we do a rounding just because I get annoyed when it does a 15 decimal point stupid thing, and we output it. And so that's just the core of it. Oh, someone's sounds on? No, yeah, just in case it was a question, that's okay. So that's the raw function, but now I looked at that and I said, well, there's a whole load of stuff I have to do with inputs, because someone could pass me a completely invalid atom for a unit type, and I might want to check that the from units and the to units were valid, and that we were still in the same dimension. I might want to do all of these things. And so I thought this is time where I should really use width. And I think width wasn't always there. Width is a more recent addition, I think, to Elixir. But however I got to this point, I've gone a long time without using it, and I thought I should really try to use it. But this is sort of the problem that I often came up with when I would try to use width, is I would say this is all very well. I could go and this, if we're on the happy path, if all of those assignments there work, then then it goes fine. But then the whole point of a with is that you're supposed to be able to handle errors. And if one of these went wrong, I wouldn't really have a clear way of telling which one of them had gone wrong. And so the oh right, yeah, that's that. Yeah, sorry, I just got my bills mucked up. This is my problem. In here, how could I tell which one of these had gone wrong so that I could do a good error message, right? And so my solution, which is possibly not idiomatic, and I probably should have actually just looked up and tried to ask questions about how it did it, is I thought what I'll do is each of these assignments I'll wrap in a tuple and I'll give them a label. Okay, so here we're matching, we're matching, this is exactly that's the same expression as before. I don't know if you can see my cursor. Oh no, if I click that. Yeah. Okay, I won't click because if I click, it's a presentation that goes to the next one. If you can see my cursor, then
yeah, we can.
Oh, good. Thank you. Thank you. I will file that away. Cool. That's the expression from before, but I've given it a label and I'm matching that label here. And the nice thing then is if one of those fails, I can have multiple clauses in the else which have the label there, and this thing comes out nil because it broke. Something went wrong with this. It tried to do a lookup in my units map, and it couldn't find that unit, so that broke and it's nil. So now I can put a nice, we don't know what the source unit is, we don't know what the destination unit is, or we can do this little match. Notice those little carrots, they've got me in the past, but I'm getting better at remembering those. Those are anchors in the pattern to say, use the value, for people who don't know, that means use the value in that variable in this pattern match. Don't actually, don't assign something on the right-hand side to this variable, anchor this one so that it's the pattern fails to match if the current value in that variable doesn't match what's on the right-hand side. And yeah, so that's just basically saying if I had tried to convert from feet to watts, then it would come up saying you can't convert this because the dimensions don't match. We can do length to length, but we can't do length to power or some other weird combination like that. Okay, so that's how conversion within units works. And that's my solution to using with. And if anyone has some other approaches to that, I don't want to present this as that was just an idea I came up with, and some other people might have some better ideas in question time to tell people. So next is operators. Okay, so Elixir ships with some spare operators, which I just imagine Jose just sort of like found some nice little sort of things that he thought would be fun to be operators, and just said, these are operators, but we don't actually, the kernel doesn't actually implement them. And so what I'd like to be able to do with these is I quite like these ones, the little arrows with the wiggles, the wiggle arrows. No, wiggles, you've got to do the wiggle thing, probably. Sorry, people with kids will know, yes. So I'd like to be able to do something like this. I'd like to be able to say, that value there on the left, that's in millimeters. And I would like that to build me, one of these representations. I mean, I know it's just as many, I mean, it's one character less to do it with the operator, but it's just sort of neater, and I like, I like doing that. And this is something I brought over from that original library that I wrote, Deaf Unit, a few years ago. And,
Robin,
hello.
Sorry, just to jump in, is it worth explaining what you mean by the spare Elixir operators?
Okay.
I've forgotten what you meant by that from your first talk. Okay,
so, well, that's what sort of was. So there are a whole lot of operators in Elixir, like plus, minus, division, and and these sorts of things, and most of them are implemented by the kernel. So the plus symbol, has a meaning. You can add two numbers together that works. But what happens is the Elixir parser will recognize all of these sequences of characters as being an operator. It'll actually parse. So you could actually take one wiggle arrow 2. If you wrote that in your Elixir program, it wouldn't be a parser error to use that in a place of another operator. But when it tried to work out where the implementation was, it would say, there's no definition for this operator here. So it's not a parsing error. These are actually recognized by the language as being operators, but when they built the language, they left these free. Some of them are actually used by Bitwise. If you use the Bitwise module for doing, working with binaries and stuff, you'll actually find that some of these, this is roll, I think this is one for roll right and roll left, and this is binary. I think that's a binary or something like that. I should know this because I've just written a huge library which uses these everywhere. So
yeah, Robin, you're correct. That's all. That's the third one is AND, binary AND.
Yeah, binary AND. Yeah. So I've just been doing this big communication library for Mavlink, which is a drone communication protocol, and so I did tons of this stuff. But yeah, so that means that Bitwise is a library that wanted to have some additional operators. And so what they did is they used some of these spare operators and defined them for use on doing bitwise arithmetic. But there are some other ones here that we can do exactly the same as what the bitwise library does. We can actually define some of these, give meaning. We can implement some of these operators. Okay, and so I'm going to use that left wiggle to make this into a millimeter measurement, and I'm going to use right wiggle to be a shortcut for the to method that we just wrote. Sorry, did I say method? Wash my mouth. Function. Thank you. Sorry, I've been programming a little bit in Dart recently, and so I apologize. Yeah, so I wanted that just to be a shortcut to the to method that we just implemented. Damn it! Function. 10 Hail Marys. Okay. So how do we do that? So this is pretty cool. You know, everything in Elixir is a function. Absolutely, definitely not a method. No one would say that. So operators are functions. And if you wanted to, this is what the spec for our left wiggle operator looks like. If you say number left wiggle unit, that's a function call that's actually going to return a tuple of a number and a unit. Remember that I can say unit there because I wrote a type spec right up in the second slide that said what unit was. It's a set. It's a set of atoms that can be there. And to implement it, we just say you don't write the bracket syntax. You actually just write the operator as it would be. We just say a wiggle b, and then the rest of it's exactly like a normal function in Elixir. Okay. So if A is a number and B is an atom, we're just going to build ourselves one of these little tuples to represent that value. And then similarly for the to, if we have one of our values and we say we want it to go to another unit, it's going to produce a unit, a float unit tuple. And all we do here is we call our to function that we wrote before. And I had to double check myself to make sure that I said function, and I did, so I win. Okay. So that's how simple it is to use those spare functions, the ones that they've built into the Elixir parser, but which no implementation is provided for in the kernel. Now, the next problem is, what if we actually want to do something with an operator that the kernel has already defined? Okay, so I want to be able to say something like this: 1 foot plus 2 foot equals Jake the pig, or 3 feet, right? So there's a problem here because that plus sign already means something. That's already defined by the kernel. And so if we want to let people using our function, now you notice that I put this up here. That's a bit of a clue because we're going to have to do some interesting things, which I'll show you next. We have to basically suppress the kernel's version of plus for the users of our module to be able to do this, okay? And the way you do that is, I thought topically that we should do a Mythbusters reference and veil Grant Imahara, fantastic person. So we are going to, so what we're going to do is, this is inside our unit module. The first thing we need to do is, because we're actually going to define functions that are called this, we have to not import them from the kernel. Otherwise, when we write a definition for plus in our module, it'll say, well, hang on, there's already plus is already, your kernel's already got a plus, so you can't use that here. And so what we're going to have to do is inside our module, if we actually need to add two numbers together, we're going to have to say kernel.plus to actually say, I know I've overridden and I didn't want the kernel plus to be here, but I'm actually going to have to go and grab, I'm going to explicitly reference the module dot function name to be able to add numbers together. And then what we do is, this is part of macros, which are awesome. And I probably swallowed the Kool-Aid a bit too much when I started Elixir because they were very, very awesome. I think some people from my earlier presentations will know that I sort of went a bit crazy with macros, but this is a normal, you know, approved use of macros. This is what happens when you say use unit. This fragment of code will basically get inserted at the place where we wrote use unit. And for what it does, just a normal import. It imports our module, and then it imports the kernel, but this is for the people using our module. It says don't import the kernel's these operators because unit is going to provide them for you. Okay, so that's all of this is what happens when we say use unit. And this is to allow us to redefine these functions inside our module without getting syntax errors saying we're redefining the kernel's versions. Okay, so let's just go, now we're getting 23 minutes in. Okay, so we've got 7. So let's just look at the specs first. We still need to implement normal pluses because people will be really pissed off with us if we override plus and you can't add numbers together with it. That would be a definite, you know, a definite downer. So we're going to have to make that work. And then if you're going to add two numbers with units together, like 1 meter plus 2 meters or 1 inch plus 2 feet, we're going to produce another one of these tuples. And the implementation looks like this to start off with. Okay, that's like forgive me for object-oriented people. This is like calling super. Okay, this is like saying instead of I'm sure there's a proper some Haskell people have just rotated somewhere in. They're not dead because they're very much alive, but there's a failed metaphor. Oh well. So yeah, so all we want to do is we've got two numbers here. So we're just going to call kernels. So kernel.plus, that's like the kernel's version of plus. And we're going to add those two numbers together. And all the operators are like that. You can actually say, you can actually use plus with brackets like that. And it will work just like, well, I mean, that might be useful if you wanted to do an ampersand operation or something. You might be able to do something cool with you in a map or something. But that's the simple version. Now we need to, if we're actually talking about units, first of all, if we're talking about 1 meter plus 2 meters, where the units are the same, and notice that that variable name is the same, so they have to match. Otherwise, this whole clause won't match. So we're talking meters to meters, feet to feet, inches and inches. We know Major Tom's a junkie. Ashes to ashes. No, anyway. Well, sorry for these stupid references, which many people will not get, I think. When the A and B are numbers and unit is an atom, we're going to just add the A and B's together and then just put a unit as a second element of the tuple, right? Okay, so that'll handle all those cases where we're adding the values of the same unit together. So that one is done. And then the last one is where we are, is where they're different units. They're both units of the same dimension. So we're always talking about length, or we're always talking about power, like we might be adding watts and horsepower together. And what we have to do is we just check again to make sure that the values are numbers and the units are atoms. Then what we say is we want to get our B value in A. So what we're going to do is we're going to translate the B value into the units of A using 2. And then once they're both in the same unit, we'll just do exactly the same as we did in the previous one. So we're just going to say the rule is for plus, is that we'll use the units of whatever the first value is, the left-hand argument to plus. Okay, so that would, okay, so we call 2, it gives us a value which has been translated into the A units, and then we can add them together. Okay, so just to go on from that, so the implementation details are similar for subtraction and also for unary plus and minus, which means like putting, if you write -1 or -7 or minus brackets some expression, it just multiplies it by -1. There is a weird little syntax thing which I've sort of skipped over in this presentation, where when we tried to do pattern matching with these, there was actually a syntax error, and there's a bug in the Elixir for that. There's actually, when you try to redefine a unary operator, you have to walk on eggshells because the parser is a little bit fragile at that point. And I can show you that how that simple the unary stuff is. If people really want to see, I'll show you what I did there. Okay, so addition and subtraction can't change your dimension, and nor can multiplying or dividing by a dimensionless number. So if we have 10 meters minus 3 meters, we'll get 7 meters. Those are always lengths. 2, that's a dimensionless number. It doesn't actually have a unit attached to it. 2 times 5 meters equals 10 meters. That leaves it as a length. 10 meter divided by 2, again, it's a dimensionless number. It doesn't have to use it. That's 5 meters, okay? However, if you start doing division and multiplication with units, then that allows you to cross into other dimensions, which is, sounds pretty cool. You can tell people what your talk was about tonight. So 2 meters times 5 meters is 10 square meters, okay? That's a unit of area. 60 kilometers divided by 1 hour, length divided by time, is 60 kilometers per hour. It's a velocity, okay? So we're changing dimensions when we start using multiplication and division. So that leads me to the next slide title. Okay, so if we wanted to do this, okay, we want to say 1 foot times 2 feet. Okay, that's like the size of a table. You've got a very small table in front of you. Okay, it's 1 foot in one direction and it's 2 feet in the other dimension. And that's going to make a 2 square foot table. But because of the way that this works, it's going to translate into the home unit, which for area is meters square. And if we wanted to, we could just then do a little wiggle and say, express that in square feet, and 2 would translate that for us. Okay. So how does this work? So the first thing we're going to need is we're going to, geez, I've got 10 seconds left. Okay, I'm going to go slightly over. So I'm most of the way through. Okay. So what we need to do is we're going to need to know how do we know that when you multiply feet together, you get, how do we know that when we measure lengths, multiply lengths together, we get area? Okay, we're going to have to have some sort of lookup table which tells us how to go between dimensions. Okay, so what we're going to do is we're going to have these little triplets of different dimensions and how they relate to each other. People who did electronics in school or uni will recognize this maybe from Ohm's law, where you have, what is it? It's resistance and voltage and amperage are in a triangle. And just at the moment that I looked at it, I can't remember which way they were, but I'm sure I could work it out in a moment. But yeah, basically the way you remember the relationship between these three is length equals velocity times time, velocity equals length divided by time, and time equals length divided by velocity, okay? So, and there are lots of different dimensions, and we can sort of, if we wanted to summarize all of the different relationships, we could make another little map like this that just tells us how all of the different dimensions are related to each other, okay, using those types that we made up before. Okay, so now we come to our final little thing, which is the how to implement multiplication. Okay, so first of all, we have to break this up into a few little bits. So here's the type specs and the simple causes of multiplication. Okay, that's the start. So we still want to implement normal multiplication, so to pass it through to the kernel. We still want to be able to take a dimensionless number and multiply it by something qualified with a unit and get something qualified by a unit. We want to be able to do the same thing the other way around, just to be able to swap the order of them. There's no way in Elixir to say that multiplication is transitive and you can make it work the same way around. You have to explicitly state both things, unless somebody knows and they can tell me. And then you might have two things qualified with by unit, like we were just looking at on the previous slide, and we're going to get that. So this one is our super, pass through to the kernel. If we're just doing two numbers, it's normal multiplication. Here, if we're just doing a non-dimensional number times this, then all we really want to do is we want to multiply. See, again, I'm having to say kernel.multiply because I'm writing this inside I'm writing this inside something where I'm redefining what multiplication means. So I have to qualify it by saying the kernel's multiplication, the one that just works on normal numbers. And the same thing for this. This is just an exact repeat of the same thing, but just with the arguments swapped around. This next one is something, I mean, I can just point you to where the code is if people want to go through this slowly, because I realize that I'm 3 minutes over at the moment. So this is in the big version, we do this, I use that same with technique I did before. I'm doing all these labeled with assignments to find out, to basically look up the A unit and the B unit's details. I want to work out with that new table, that new set of those triangles, the triangle table that I was just showing you, we have to look up what the result dimension would be by just basically doing some pattern matching on the tuples in there. And I do that with this filter. Okay, I'm working out I'm just going through that that map of tuples, and I'm trying to work out which thing match. We're basically pattern matching to work out which, we're multiplying these two things together at the bottom of the triangle. What's that thing in the first position in the tuple that's going to be our target, our result dimension. And then here we have to work out what the result unit is. And what we're doing there is we're just looking up in the units. We're trying to find the unit which has got a coefficient of 1 because that's the home unit. So we're just looking up, in the case of area, we're finding out that square meters is the home unit for area. And then once we've got all of those things, we can just basically calculate the result down here, which is just the A value times the A coefficient times the B value times the B coefficient. I've just realized actually that this won't work for, this is not going to work for temperature. I haven't tested that yet. So that will probably break for temperature. I need to put another clause in there for those weird ones where we don't just have numbers. So thank you. That's debugging at work. And then here we just have all the different error conditions that we could have when we're trying to do multiplication. Division works very similarly to that, multiplication and division. Division just has to look up different positions in that triangle to work out what the result dimension is. So 5 minutes over. Questions or yes. Oh,
sorry, I just wanted to ask a question on that last slide. You put the questions up.
Okay.
So you've got ACOM's details, which is a pattern match. Can you explain a little bit more about that? And in the previous slide as well, you use that.
Okay, this is that with technique that I'm using, where I wanted to. Originally, I started off with. Oh, hang on. Can you go on mute again?
Oh, sorry.
Yeah, no worries. So originally when I was trying to use with, I would just do this second part of the tuple. I'd just be trying to assign. This would be the pattern, and I'd be trying to match. I'd be trying to look something up from the units map. Okay. And this would be the pattern, and I'd be trying to look up something in the units map. But the problem is when we get onto the errors, if one of those had failed, if one of these lookups here had failed, I wasn't going to know which one of these things here had failed to be able to write a useful error message for the person, when I get down into this else of the with. And so what I do is this is my cookbook for when you have a with. You have a with a whole load of different things that could fail in it, and you want to be able to write you want to know or get some information about what part of the with failed. You wrap the pattern and the thing that you're assigning to it in a tuple, and you give it some label that allows you to identify which line, the A conv details, the B conv details, the result dimension, or the result unit. These are 4 different stages of the with that could fail. And so if I label them like this, then I'm able to match inside the else. I can match on which section of the with had failed and then give an appropriate error. I could return an appropriate error message depending on which thing had failed. So if I couldn't find the conversion, the details about the A unit, I'd say, well, I don't know what unit that is for the left operand of multiplication. If it was a B, I don't know what the unit is for the right operand. If my little table of triangles wasn't complete and I can't work out what the result dimension would be, like maybe we're multiplying horsepower with area, and we're going to come up with some weird off-the-charts thing. But firstly, I would rather my library fail at that point so that I can go and scratch my head and work out what that unit should be and if it's valid or if I've made a mistake. Because maybe if I've multiplied two things together and they've gone off into some weird dimension, I don't want to be calculating something in that dimension. So we're just saying, I can't work out was you gave me a horsepower and you gave me, you know, power and you gave me area, and we multiplied them together and I don't know what that means. So we're just basically saying, I don't know what the result dimension is. We've stepped off into the twilight zone. And then here, yeah, and this is just, we can't work out what the final unit is, which should never happen. Does that make sense?
Yeah, that makes sense. It actually, I was kind of looking at it and it almost looks like a type class in Haskell, which kind of, it's not, but confused me. So it's actually used for the output rather than the input. So that makes sense.
Yeah, it's just labeling them so that I can, it's almost like labeling, I'm sorry to use words like exceptions
kind of,
or things like that.
It's not,
yeah,
but confused me. So it's actually used.
Right. But yeah, so that was it. And by the way, apart from flying, my recent hobby has been identifying episodes of Star Trek Next Generation, which have very familiar continents on Class M planets. Yeah, if you happen to recognize that one, extra points. But are there any other questions?
Yeah, I was going to ask one, Robin. Great talk, by the way. I was giggling away at some of your comments, just was on mute so you couldn't hear.
Yeah, no worries.
So being fairly new to Elixir, one of the things I sort of keep coming across in, you know, newsrooms and things like that, news groups and stuff is, you know, performance around calculations for floating point numbers and that sort of stuff, right? And I'm sitting here wondering, you know, and I hear people talking about using native inline functions and that sort of stuff, and I'm thinking, well, you know, how bad actually is it? Did you, and especially here in this scenario where you're using your conversion to go to your base and then back to your target outcome, are you finding, did you like do any benchmarking, or were you finding that that was particularly an issue for you in terms of performance, or is that just, you know, just only for the real revheads that care about sheer assembler performance?
This is not being, the way this is being used, it's not being used in, because it's actually, see, if I was using this inside a simulation or something that was real time, I wouldn't be bothering with the units as much, because I would have worked them all out ahead of time and made sure it worked, and then I would have all stripped it down. And that was actually the idea of my first library. I was trying to make it all happen inside macros so that I could get it all out of the way at compile time. But in this case, I'm actually using this more like, what's it called? Notebook? What are they called? What's the...
Oh, no, like Jupyter books?
Jupyter, yeah. I'm sort of using this more like, in this case, I'm using it more like Jupyter, because I'm sort of going step by step, doing some calculations for an aeroplane design or something like that. And so what this is all about going very carefully and tracking my units and making sure that I'm not mixing things up or coming to a conclusion that you know, could be a flight safety issue for a plane. So yeah, but I mean, that said, I once wrote or started writing, I was mucking around in doing a convolutional neural network, actually just in normal Elixir. And of course it was, you know, anything that's outside of a GPU is going to be slow for that. But it was a lot faster than I expected. And I mean, I suppose they haven't been able to spend as much money on the Erlang VM as they had on the Java VM or whatever to optimize or do JIT, you know, code or stuff like that. So, I mean, I think it seems pretty fast, but I've never really had to, I'm just trying to think if I've done anything which is, I mean, certainly I've done soft real-time stuff like the flight simulator, the autopilot talk that I did, where I was controlling X-Plane I was controlling an aircraft in X-Plane from Elixir, and I was using a library in Elixir to do that. And I mean, but in that case, things like all the Elixir binary handling is so fantastically fast and streamlined and efficient you know, and especially I think writing that library, which is called Mavlink, Elixir Mavlink. And it's called Mavlink on Hex. But, you know, there are some things which Elixir is just, I think must be really, I get the impression is really fast for, because it's certainly way faster than, I mean, I'm not saying much, it's way faster than Python. I love, you know, I do I do a lot of work in Python, but for that thing of like just marshalling and firing off binary messages on UDP between an aircraft and a ground station, all that sort of stuff, it, you know, maybe it's not so much the addition, I'm getting off topic. It's not so much the arithmetic, but it's the handling of some of the other things that it does that are so fast that I think keeps it pretty zippy.
Robin, are there any linear algebra bindings for Elixir?
Algebra?
You know, any linear algebra libraries, like the BLAST libraries?
No, no, there might be. I've done, I mean, there's nothing like NumPy. I mean, that was the weird thing. That was actually why doing a neural network was so bad. You know, you'd think it was so bad because everything's a linked list. And so you can't just address a big chunk of memory, which is what we normally do. But it was sort of, as I was writing it, that was what I was working on at the first Elixir camp I went to a few years ago. But it was, so what would happen is you'd be deep down and saying, this is terrible, and then suddenly something would happen with the way that you were processing it. Would you just say, wow, that's actually really efficient, and I didn't have to do any memory, I didn't have to do a malloc to make that work. I could do all of that with immutable variables, you know, and it's like, it was interesting how much you could do with immutable variables without having to,
I'm pretty sure there's some in Erlang, Richard.
Okay.
I went on a rabbit hole a while ago to do some yeah, fancy that, some Fourier analysis, and I ended up with like trying to find a vector library, and I found a quite good vector library in Erlang. Don't ask me what it is. I'm probably lying. I could be deluded. Everything I say is wrong, but yeah, I'm pretty sure it's there.
Okay.
I had a quick question about the use of floating point numbers as well. Like, do you risk running into sort of rounding issues?
That's why I put that round 14 at the end of the to function. That was like in the end of that pipe. Well, yeah, I rounded it just because I found it. I mean, for my purposes with this particular library, where did I put it there? There I go, yeah, down here. I just rounded it deliberately to 14 places so that it was one less than, I did get something weird in one of my tests when I didn't round it. And so I did round that one. I mean, there are other, yeah, I suppose there are other ways you could do it. Like, I mean, you could, I mean, I know that in linear algebra, when we're doing homogeneous coordinate matrices, we often have that little, the number down in the corner, and it acts as a denominator for the whole matrix. Sorry, I can't remember what it's called. But that allows you to sort of like not work with really tiny numbers. But I suppose for this particularly, because I'm not really ever going to be working with, I have to watch out when I go to my home unit and then back out again that I haven't translated through some stupid, you know, tiny value near zero that makes it all, maybe that would be a good check. Maybe I should just put a value on, you know, if when we're halfway through the 2, if the value is smaller than, you know, 10 to the minus 12 or something like that, then raise some sort of, raise an alert saying, look out, we're going through some sort of asymptotically weird calculation here, and the results might be unreliable. That might be a good idea, actually. Is that sort of, I mean,
well, yeah, I don't even really know how floating point numbers work in Elixir. Like, I wasn't sure if they were machine floating point numbers or not, and so yeah, whether like 0.1 is actually 0.1 or if it's approximately 0.1, that kind of thing. Yeah.
No, I don't.
It's implemented the standard IEEE way, like every other language.
There you go. Quickly looks up the IEEE version. Yeah, I mean, it would be, since the purpose of this is to be very careful with calculations, it would probably make sense to put some sort of check on this interim value to make sure, or just to make sure that we don't go through some sort of very weird thing. But generally, the sort of values we're talking about are not, we're talking about wing loadings and speeds and things like that, at least for my use of it. By the way, I didn't actually mention in the slides that this is part on GitHub under Robin Hilliard. This is part of a library called Lightplane, light as in light, LIGHTPLANE, and that's basically because this is part of my implementation of this book to the Lightplane Designer's Handbook. But the unit library's in there if people want to take a look at it.
Robin, just on the floating point issue, there are arbitrary precision floating point libraries. They do tend to be slow, which might not be appropriate for you, but that might also be something you could think about. Yeah,
we could. I mean, and presumably they probably do the same sort of operator overloading that we've been showing in this presentation. Because if you had a library and you wanted to overload, you wanted to make plus or division or whatever work with one of those with another representation, then you might do that with this. I don't
really know how they work, but they're quite slow.
Sorry, I just have one other question, which was you showed us how to override existing math operators, which I didn't even know you could do. Is it something we should do? Like I know, say if you're doing that in some other languages such as Ruby, you're probably going to get a slap on the wrist. So is it a good idea?
How can they say that when they invented mix-ins? But sorry, I did like Ruby about it. But the notes, the things in the Elixir manual when it talks about this, it says frowned upon, but they make an exception for domain-specific languages, which I think that's what I'm talking about here. Is we've got and it's the same with Bitwise. Bitwise, you want to, if you really are going to be working if you really are doing some sort of arithmetic with values that are more complex than, I don't know, complex numbers even, or, values that are not normal numbers, then it does make sense. I do think for code clarity, it does make a lot of sense to keep using the same sorts of addition, multiplication, subtraction sort of operators, because it does make the code nice and readable, and it does correspond to, how when people think about adding two measurements like this together, they really, plus is a good representation of that. And I suppose the reason I also feel not too bad about this is I have provided the pass-through. That is, when we implement this stuff. Where are we? When we come on. Now, this is why I hate doing all the builds now. I should have put the time down to 0.1 of a second. Right, see, because we do that, because we do, the thing is, we've got multiple clauses, and the very first function clause is the default use of plus. So I think this is very low risk in doing it this way, because and all of these other signatures of the function are distinct from just number and number. So we've actually kept the original meaning of plus. Even when you import this, we haven't, if we're just passing it through to the kernel. And so these ones are, and these ones just handle additional cases. But this would be all completely transparent to someone who is just adding two numbers together after using our library or using our module.
Is there some risk, for instance, that there's like another kernel plus that you don't know about?
No, there's only, because then they would be, oh, you're saying that if kernel had implemented plus for something other than numbers. Yeah, I suppose so. But
yeah, you do risk that problem. I think it's pretty low risk overall because you're opting into this when you're importing the module. Or using it.
It's also
and so it's scoped to that module where you're using it, and that's the important part.
Can be even more specific than that. Like you can do use just within a function.
Yeah, within
a scope there. So it's just whatever context you define it in. It's only going to override in that place. It's kind of not like Ruby, where if you monkey patch something, it's everywhere globally. It's just very localized to where you do that use statement.
Yeah.
Hey, Robin.
Yeah.
I did see just somewhere the other day, there is a language that is devoted to calculating units of measure and the like called Frink, F-R-I-N-K. You might be interested just in having a look at that. So
some ideas. Yep.
Yeah. Check it out.
Yeah, I mean, I've often thought, like, I mean, there's things like this. I'd love to have, like, for instance, I've often thought of having a spreadsheet that had, like, that you could use addition and subtraction and stuff on, but you could use it on distributions, so that you could actually, if you were trying to do Monte Carlo modeling or something like that with risk, you could actually add two distributions together and you just use normal sums and stuff to have fuzzy numbers, like having fuzzy results or whatever turn up in a spreadsheet cell. So
Kind of like R.
Yeah, is that what R does?
Yeah, it's sort of one of the things it does.
Okay, well that's that. Okay, now I've written a library in R and I didn't even know it did that, but I suppose it was a very simple one to interface with one of our APIs. So
I've only ever rewritten an R library in Ruby to make it faster. So take what you will from that.
Okay, yeah, absolutely. Yeah, I mean, I think this is a domain-specific language, and I feel I was comforted that the Elixir documentation actually mentions that as a specific reasonable case for doing operator overloading. Yeah, and Bitwise is another good example. And I've had problems because I use Bitwise a lot in my Mavlink library, and every now and then, there were some things that you had to sort of like think a little bit about the operators. But at least the nice thing about this is the operators are just functions, which is a nice, FP sort of thing to be doing. I'm pretty sure that's pretty common in a lot of, obviously Lisp or any other sort of, languages inspired like that. Operators as functions isn't a new thing. But, even when I'm in here, I can still be explicit about exactly which function I want to call by qualifying it with a module name in front of it.